Alright, this is Mr. Go. Welcome back. Today we're going to take a look at orbital notation, which are really just energy diagrams for electron configurations. Now, a few things to get started with this. We first need to understand what the rules are for orbital diagrams, okay, or for orbital notation. The first rule is the Aufbau principle, and the Aufbau principle states that you can't electrons actually will fill into the lowest energy levels possible. Okay, so the Aufbau principle states that if I have an energy diagram like this, what happens is electrons will always fill up the lower energy levels first, right here, before they start moving up, okay, to higher energy levels. And this is my energy diagram. So that's the Aufbau principle. Now, the next principle is the Pauli exclusion. Pauli exclusion. And the Pauli exclusion principle states that when an electron, which happens to be represented with a half arrow like this, fills in one of the blanks, for example, this is the 1s orbital, you can't have another electron that's pointing in the same direction in the same atomic orbital. What happens is they end up having the same set of quantum numbers. So the Pauli exclusion principle states that no two electrons can share the exact same set of quantum numbers. Otherwise, it would be exactly the same electron. So that doesn't work out. They always need to be pointing in opposite directions. Okay? And then the last rule is Hund's rule. Hund's rule. And Hund's rule states, okay, that if I happen to have an energy level, let's pretend that this is the 2p orbitals, and the electrons happen to be present in those energy levels, okay, what happens is that the electrons need to spread themselves out before they actually pair themselves up. I compare it to kind of like sitting on a bus, like taking public transportation. People will go ahead and take up the empty rows first, and once all the empty rows are filled up with one person, then they start to pair up in those rows. So if I happen to have 4 electrons that need to fit into the 2p orbitals right here, what happens is the electrons will spread themselves out before they start to pair themselves up. So this is the correct notation for 4 electrons in the 2p orbitals. And if I had something like this, okay, this is incorrect. Okay? And the nice thing about this, about Hund's rule, what it does, it really tells us what kinds of bonds these atoms would form, or the possibilities of bonds. For example, with this one and this one, both of those are unpaired. And because they are unpaired, I can get another electron to come in here and another electron to come in here. And what this tells me about that atom and its electron configuration is that it can form 2 single bonds or 1 double bond with another atom. Okay? So those are the rules for electron configurations. Okay? Now let's take a look at these orbital diagrams. Let's do a simple one, like lithium. Okay? Now let's do the electron configuration for lithium first. This is 1s2, 2s1. Now, the energy diagram would look something like this. So we always draw the arrow pointing up. We always draw E, which means in energy, and this is just increasing in energy. And what we do is we fill in the blanks. So for every single one of these orbital terms, I have 1s. I'll have a level for it in the energy diagram. And if I have 2 electrons right here, that means that I have 2 electrons right here, one pointing up and one pointing down. Remember, the Pauli exclusion principle says that they need to be pointing in opposite directions in the same blank. And then let's take a look at the next one right here. It's 2s1. And because there's 1 right there, that means I have 1 arrow pointing up right there. And this is the energy diagram, or the orbital notation, for lithium's electron configuration. All right, let's take a look at another example. Okay, one with a little bit more electrons, like something that's in the p block. Let's take a look at phosphorus. Okay, 1s2, 2s2, 2p6, 3s2, and then 3p3. All right, so what's the orbital diagram for this? So here's my energy diagram. Okay, let me go ahead and fill in the blanks with those terms. So 1s down here, 2s over here, And note that you can put 2p directly above like this, but I kind of like to go ahead and write it off to the side. And the reason why I like to write it off to the side right here is because it kind of helps me visualize it and keep things organized in certain columns. Like the s orbitals will be in this column, p orbitals will be in this column, and so forth. So let's go ahead and move it off to the side. Let's continue on. So 2p, and then I got 3s, and then 3p, and those are the orbitals that we need to fill in with those electrons. So 1s2 fills this up, 2s2 fills this up, 2p6. Now watch when I fill this in. I'm actually spreading the electrons out before I actually start to pair them up. So 4, 5, 6. That's the 2p6 that you see right there. 3s2 comes in right here. And then 3p3. Again, spread the electrons out. That's Hund's rule before you start to pair them up. Now what this does is it tells us that phosphorus can form a total of 3 bonds. Okay? I can have a combination of 3 single bonds, or a double bond and a single bond, or maybe even a triple bond between another atom. So that's the energy diagram for phosphorus, and knowing the energy diagram and how to draw it tells us what the bonding characteristics of that atom would be, or what that element would be. One last example. Okay, let's take a look at something that's in the D block. Let's take a look at iron, for example. So let me go ahead and write it up here so I can have a little bit more real estate. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay, so this is my electron configuration. Now let's go ahead and do the energy diagram for it. So here we go. Let's write the energy arrow. Let's go ahead and fill in the blanks. Okay, 1s, 2s, 2p, 3s, 3p, 4s, and 3d. Now I'm going to put d over here. Now the reason why it's got 5 blanks is because if you look at the d orbitals, there's a total of 10 total boxes as you go across the d block. That means you can fit a total of 10 electrons, and 10 divided by 2 gives me 5. If I can fit 10 arrows total, then I should have 5 total orbitals, 5 total blanks that you see right here. Okay. All right, now let's go ahead and fill them in with some arrows. Okay, so we've go ahead and filled them up with the arrows, and you'll note that when we filled the d orbitals out, we spread the electrons out before we started to pair them up. And what this does is it allows us to view that these are the unpaired electrons in the d orbitals for iron. Okay, so that's it for today. Check out the next video on some exceptions to some of the rules that we mentioned earlier, like the Aufbau principle, the Pauli exclusion, and Hund's rule. I'll talk to you soon.